circling the Sun. Together, they form the solar system. In all the universe, as we know it today, the Earth is the only body able to support life. Life on Earth is possible due to a unique combination of factors. One is that the Earth's axis of rotation is tilted at 23.5 degrees from its orbit, which is the circle it makes around the Sun. The result of this tilt is that the northern and southern halves of the Earth, its hemispheres, receive different amounts of radiation and energy throughout the year, creating our seasonal cycle. Life on Earth also owes a lot to its natural satellite, the Moon. There are other planets in the solar system that have satellites, sometimes several, but our Moon, at a quarter the size of the Earth, is the largest relative to its planet of origin. Its gravitational pull is powerful enough to create the cycle of oceanic tides. It would also have deflected many asteroids during the formation of our solar system and have protected the Earth from their impact. What you are seeing is an accurate model of our solar system. The 4 planets closest to our Sun are Mercury, Venus, Earth, and Mars. These 4 planets are all made of solid rock, and their sizes are of similar magnitude. But again, one of the unique characteristics of the Earth is its distance from the Sun, which allows enough water to remain liquid and sustain life. Beyond Mars is the asteroid belt, composed of a huge number of rock and ice bodies ranging in size from a few inches to more than hundreds of miles across. Further still from the Sun are Jupiter, Saturn, Uranus, and Neptune. These 4 outer planets are much larger than the inner ones, and their composition is different. They are the gas giants. If they were closer to the Sun, the gases that make up their outer layer would warm up and vanish into space. Beyond the orbit of Neptune lies the Kuiper Belt, a vast area where millions of asteroids lie dormant. Past this point in the solar system, there only seem to be dwarf planets like Pluto and very long-distance comets. Some astronomers speculate there may be a 9th planet circling our Sun, but its existence remains unproven. This is our immediate neighborhood in space, one very small corner of a vast universe. Before we look beyond our solar system, let's just take a moment to admire some of its planets more closely. This is Mars. Like Earth, Mars has an atmosphere, a thin layer of gas held by gravity onto the surface of the planet. But the rocks that make the core of Mars are less dense than those of Earth, and Mars is also half the size of our planet. The gravity at the surface of Mars is thus much weaker than that of Earth, and its atmosphere is consequently much thinner. This is in stark contrast to its neighbor, the fifth planet from our Sun, Jupiter. Jupiter is a gas giant 10 times the size of our planet and 300 times its mass. In fact, it is larger and more massive than all the remaining planets in the solar system put together. Had it been slightly more massive still, then the gases at its core would have been compressed and heated enough for Jupiter to light up, and it would have become a star, just like the Sun. We see on the surface of Jupiter come from the gases it's made of. These bands of color are the visible indicators of the massive gas storms swirling within its atmosphere. The largest and most fierce of these storms is the Great Red Spot south of Jupiter's equator. This one storm is twice as large as our planet, and was already raging on its surface when we started observing Jupiter nearly 400 years ago. Even with winds blowing at more than 400 miles per hour, this huge storm takes no fewer than 7 days to make a full circle on itself. There is a jewel in the crown of our solar system. All the gas giants have more or less visible rings, but those of Saturn are truly spectacular. the rings of Saturn have a width of 5 times the diameter of planet Earth, but they are less than a mile thick. The reason we can see them so well is that they're made of billions of ice particles, which together act as a giant reflector for sunlight. Because of the angle it forms with the Sun, this shadow that Saturn casts on its rings is impossible to observe from an Earth-bound telescope. Only probes from the Voyager and Cassini missions could take photographs of it and send them back to Earth. Meet Enceladus, one of the 47 moons of Saturn. It's a small world, but of particular interest to researchers. A few meters below its icy surface may lie an ocean of liquid water. At this distance from the Sun, it's unclear how much sunlight would reach this water. But with traces of methane, carbon dioxide, and water vapor already observed, several building blocks for life are known to be present. We cannot yet verify that life does indeed exist on Enceladus, but it remains one of the most serious leads we pursue today to find life elsewhere in the universe. The Sun is more than 100 times the size of Earth. At its core, where the pressure is at its greatest, the temperature rises to more than 50 million degrees. Under these conditions, atoms are forced to combine and form other elements. This is nuclear fusion on a grand scale. Look around you. Can you see this bright band running across the sky? It's the Milky Way, and this is where we are going. Nothing in the known universe moves faster than light. At the human scale, it appears instantaneous. But in fact, Traveling at 186,000 miles per second, light from the sun takes 8 minutes to reach planet Earth. Near Neptune, the outermost planet of our solar system, light has already traveled for more than 4 hours since it left the sun. We are now near the furthest point ever reached by a man-made object. 40 years ago, the Voyager mission sent a probe into space. This probe keeps traveling, and today, the light from the sun takes nearly 20 hours to reach it. It is now the furthest man-made object in space. But to get to the very end of our solar system, we must go further still and travel a full light year. It is the distance that light will travel within 1 year. From this point, we must keep traveling for 3 more light years in order to find the first neighbor to our solar system. This star is called Proxima Centauri. Space is not empty. Although they have a very low density, we find various gases and dusts there. All stars are driven by the same powerful nuclear reaction at their core, but even this process is not infinite. In our sun, it will come to a natural end 4.5 billion years from now. After a last burst, it will simply stop burning, and the remaining gases will spread into space to form a nebula. This one nebula spans 10 light years. It's more than 10 times larger than our entire solar system. Some of these nebulae can spread over thousands of light years. In the middle of it is a white dwarf, the remains of the star from which this cloud originated. Stars that are much more massive than our Sun have a very different destiny. They implode when they burn out. These are the supernova. Debris from these massive explosions scatter across regions far greater than simple nebulae. But the end result is always the same. The clouds of gas and dust that will form from the death of these stars are the birthplace for the next generation of stars to come. Over millions of years, the particles of these clouds will gather to form new solar systems just like ours. Everything we see in the universe is the result of this endless cycle. This is our galaxy. It is a disk as wide as 100,000 light years. It's the side view of this disk you can see in the night sky from Earth. We think our galaxy contains as many as 100 billion stars. Some smaller, some much, much larger than our Sun. If you are wondering, our solar system is within one arm of this spiral, right there, 26,000 light years from its center. For a long time, we believed there was nothing greater than our galaxy. But now we know it's only one part of a much larger whole. In ancient Greece, people named our galaxy the Milky Way because they could only see the edge of its disk, and it looked like milk in the night. They could locate themselves and predict seasonal cycles from its movement in the sky. But in those times, we thought that what we saw at night was all there was to the universe. Thanks to centuries of scientific research and to the development of new technology, we now know that the universe is much, much larger than what our eyes can see. What you see here is the local group. It's a cluster of a dozen galaxies, each as large as our own Milky Way. This local group makes for billions and billions of stars altogether. All these dots you see are galaxies that we know and study today. All their locations are accurate. This is the largest observation of the universe we can make today. On a very large scale, galaxies group into a cosmic web that holds together all the visible matter in the universe. These superclusters are the greatest astronomic structures that we are aware of. But this is not the end of the universe. There may be more galaxies beyond what you see here. It's only that since the beginning of the universe 13 billion years ago, the light from those stars has not yet had the time to reach the only point we can see it from, Earth.